So what we ended up doing was combining the LED drivers alongside motor drivers for control. In this case, we used the L298 thanks to its 3 amp upper limit on each channel, and we got it working really nicely as far as the level of control between the control and information sharing between the two. And all of this, in the meantime, is controlled from an Arduino. To be easy to use, they already have a pre-built library and everything. It's really awesome. Unfortunately, after 2.4, 2.5 amps or so, the muscles actually start melting due to the material. So we had a number of issues in prototyping for that and developing the control system and limiters to make sure that our muscles did not melt or atrophy while in use. We also found that feedback can be pretty easily installed if using a potentiometer or even a temperature sensor. But potentiometer is easy to use to calibration mechanisms. And so you can actually adjust for everything, similar to how a servo would actually work. And installation, at least for our purposes, was sort of pick and place. Our muscles were made with loops in them, so that we can just be put on a hook and be done. And otherwise, in future, the biggest issue, as we told you, was the melting, and of course the operating currents required of 2.5 amps. So for future optimization of, if anyone wants to use this technology, you'd have to develop a line that does not require 2.5 amps to actuate to full potential, and is also capable of not melting at such a close area to its actuation range, because that leads to a lot of issues. So if anyone has any questions?
Did you look at methanol as an alternative to?
Yes, we did. The reason we wanted to use this was because this was not as well documented, so we wanted to explore something new. But also, this was developed by Dr. Bachman's research group here at UT Dallas. So we had a lot of communication going on with them as far as ways to optimize these muscles. And we actually tested out a few different materials. The one we went with in this example was 50-pound fishing line that was coiled alongside copper wire. The other one we tried was silver-coated sewing thread, and that one worked as well, and actually worked at much lower operating currents of 100 milliamps instead of 2.5 amps. The counter for that was you had to go to much higher voltages, depending on how you folded up the sewing thread to adjust for the resistance.
How would the correct compare to less current or the same amount?
The 9-volt is certainly much more efficient, but at the same time, for the range of actuation, we actually get more actuation percentage-wise with these guys.
So is there research going into looking into reducing the current requirements of this? Like, is that actively being pursued?
Yes and no. The current, this research was based off of research done with carbon nanotubes, which require significantly less current, but currently have slightly lower actuation based on the last papers I read. Any current research going into modifying the material so that to optimize it for this process, I have not seen any of this currently going on, unfortunately.
I missed, I guess your motor, is it using a piezo type motor or a step type motor, or is there any motors involved at all?
No motors involved, just artificial muscles.
Just one?
Artificial muscles. So
What's an artificial muscle?
the artificial muscles, what we do is we take a hobby motor, put these artificial muscles, attach them to the motor, and just have it coil.
What kind of motor?
Hobby motor, okay, so a standard 3-volt hobby motor for...
Just a DC motor?
Yes, yeah.
Okay, brushed, non-brushed?
Brush.
Brushed, okay. Simple motor?
Yes, simple motor. We initially were going to use a drill, but we found the drill that had too many inconsistencies to just natural release and pull of the trigger. So we found that having a DC motor allowed for much greater consistency when producing these, so we could
use electric, we wanted to use electric thermal energy, which is why we were in around the copper wire with it. And, the reason why we were using a motor charger, he was mentioning motor charger, was that it was supplied, basically we use an H-bridge. So the L298 is a TN Texas Instruments chip, is a full, well, no, actually, no, not an H-bridge, it's actually a full bridge. So we use it because it would supply sufficient current for us. So we were having trouble